Hi guys, you're welcome back to my channel. In this video, I'll be taking you through reduction formula. So under integration or antiderivatives, we encounter situations where we have to perform series of integration that follows a pattern. Once that pattern is identified, we usually try to get a general formula for that so that whenever you get a sample problem, you just use the reduction formula or the general formula given, then straight away you get the solution. One of these situations is the integral of x to the power n e to the power x dx. Whenever they give you x to the power, maybe x to the power 4, x to the power 5, x to the power 6, so whatever the number of n multiplying e to the power x, you know that this is integration by parts, right? But we've realized that whenever you do this, it's always follow a pattern. And the pattern is whenever we take the first integral, okay, first integration by parts, we end up getting the x to the power n itself, the e to the power x also, minus n times integral sign x to the power n minus 1. So the power will be reduced by 1, multiplying e to the power x dx. Then it comes back to simplify the reduction formula as the first term will be remain x to the power n e to the power x, right, minus n times Rn minus 1, where Rn minus 1 means that you realize that this Rn here, right, is equal to this whole expression. So if I say Rn minus 1, meaning that whatever n is in this equation, you subtract 1 from it, and that becomes your right side of this expression. So in view of that, I do have a problem here for me to take you through. Okay, so it says evaluate the integral of x cubed multiplying e to the power x dx. Okay, so integral of x cubed e to the power x dx, and you realize that this follows what I have here. Okay, so my x to the power n is now x to the power cube. My e to the power x is also my e to the power what x, right? Dx. That not it. Yes. So let's see how we solve this problem using the reduction formula given up there. So it says that for the first round of reduction, you have your x to the power n e to the power x being maintained minus n times the integral of that expression where you have reduced the power of the x towards by 1. Okay. So meaning that our first Rn, okay, Rn, here you know that our n is what 3 as we begin because the question says x cubed multiplying e to the power x. So 3 will be equal to, we just maintain this x cubed e to the power x, right, minus n, and the n is still 3. 3 multiplying the integral of the expression x to the power n minus 1. So meaning I have to reduce the n here by 1. So I'm going to have x squared, right, e to the power x. Then I maintain my the x here. So this is the first reduction. Okay, this is the first reduction. And within this reduction, we realize that we are done with this section because the integral sign is not here. But the integral sign is here. So meaning we have to still enter this section. So I'll have my expression to be minus 3. So within this, I will take my integral out. Okay, so this is just a coefficient. So integral of x squared e to the power x now happens to be the same as what our reduction situation. So here what it says is you take your x squared e to the power x squared e to the power x minus 2 times what integral, then we reduce this by 1. Okay, so making x e to the power what x. So this is a pattern. This is a pattern. So it repeats itself until you exhaust the power of what x. So x to the power 3 e to the power x minus 3, then the expression goes x squared e to the power x, right, minus 2 times, then you open your bracket once again. So now it's x e to the power x, meaning the power of x is what 1, right? So what it says is you repeat this here x to the power x, then minus, you reduce the power of x by what 1. So 1 minus 1 is 0, meaning x is going to vanish, right? So we're going to have integral, and here to the n it becomes 1. So my n, instead of becoming 1 times the integral of, okay, so 1 times the integral of e to the power x. So at this point, I think we're almost done. We have exhausted the power of x. So I'm having s cubed e to the power x so I'm having, yeah, so I'm having s cubed, so s cubed, let me write somewhere here, s cubed e to the power x, right? Then minus 3. You have to expand this whole expression. Expand this whole expression. But you have to be very careful in your expansion. You have to be very, very careful in your expansion. Remember, this 3 here is covering everything. And within this whole thing, minus 2 is also covering everything here. So you have to take care of the signs here. I mean, you have to take care of the brackets. You have to take care of the bracket. So let me clearly show it here. Let me clean this bracket that I illustrate it well. So my first bracket, which is the what 3, okay, the 3 brackets is the one coming out. Okay, so that one will come out as this. That one will come out as this. Then the 2 is also having another bracket. So the 2's brackets will be here, right? Okay. So now let's see. S cube is a power x minus. So now I suggest we do the outer one first, right? We do the. No, you let's maintain the outer and do the inner. So minus 3. So minus 3 multiplying minus 3 multiplying s squared e to the power x, right? Minus, here, let me do the expansion in the inner one. So 2 also multiplying x e to the power x, right? Then here, remember integral of e to the power is the same as e to the power x. So minus e to the power x, right? This, everything will be plus c because you're doing indefinite integral, right? You're doing indefinite integral. So let's see. So I still go on with my expansion here. So I'll have s cubed e to the power x, right, minus 3 open brackets. Then I do what I have here. E to the power x, s squared so I'm gonna have of these interferences. So s squared e to the power x, right, minus, this gives 2x e to the power x, e to the power x, right? Then here will be plus 2e to the power x. Then I'll close it. Then I'll still go on with my simplification. So minus 3s squared e to the power x, right, plus 6x e to the power x, then minus 6 e to the power x plus. So is there any way we can simplify this expression? No, they are all of different terms. So in all, this is what we get after